If we plot any graphs of quadratic equation on the xy plane, it looks like a parabola. Either the parabola will be concave upwards or concave down. So this concavity, whether it's going to be face up or face down, depends on the coefficient of x square. Let's say if this is my general form of your quadratic equation. So in this case, depends on the value of a. So if a is positive, it's going to be concave up. And if a is negative, it's going to be concave down. So now, if I talk about the vertex form of this parabola, so the vertex form of a parabola looks like a into x minus h whole square plus k. So this is the vertex form of your parabola. And in this case, where h comma k is the coordinate of the vertex, this turning point is what is known as the vertex, which is h comma k. So in this case, again, this turning point is known as the vertex, which is h comma k. And obviously, again, this coefficient of this a is the same as the coefficient of x square in the general form. So now this is about the vertex. So whenever they give you any equation in general form, and if I need to find the vertex form of that particular equation, so what I can do is, so I can find the value of h by using the formula which is minus b over 2a. And I can also find the value of k by substituting h in the original function. So let me take some example. Let's say I have f of x or y is equals to x square plus 4x plus 2. So this is the general form of your equation of a parabola, and I need to find the vertex form of this. So in order to find the vertex form of it, as I can say it very clearly in this, a is 1, b is 4, and c is 2 if I compare this with my general form. So in that case, what I could say is the value of h is nothing but minus b over 2a. So that is the reason. So h will be equals to minus b, which is minus 4, over 2 times, and a is 1. So which means the value of h is minus 4 divided by 2, which is minus 2. And if I need to find the value of k will be equals to substituting the h coordinate into the function, which would be something like minus 2 whole square plus 4 into minus 2 plus 2. And if I simplify this, so this is going to be minus 2 whole square is positive 4. So positive 4 and negative 8 plus positive 2. So which is nothing but negative 2. So in that case, the vertex of this quadratic equation is minus 2 comma minus 2. And if I put that in my form, so and in place of a I have 1. And in place of x, I have x itself. And in place of h, I have negative 2. So which is negative of negative 2 will be positive 2 whole square. And in place of k also I have negative 2. So if this is the general form of your equation, which is x square plus 4x plus 2, this is the vertex form of that particular equation. So now if I talk about the line of symmetry, or you can also say this is an axis of symmetry. So as we know, this is the vertex of your graph, which is h comma k. Again, if I talk about this graph, so again, this is your vertex of your graph, which is h comma k. So in this case, axis of symmetry or line of symmetry will be a line which splits the graph into exactly two halves, and that always passes through your vertex of your parabola. The line of symmetry or axis of symmetry of a parabola will be a vertical line which passes through your vertex. So that is the reason the equation of vertical line is x equals to some constant. So since it is passing through the vertex of your parabola, so that is the reason it is going to be x is equals to h. Or since we know that whenever I have any quadratic equation in the general form, which is ax square plus bx plus c, I can say h is nothing but minus b over 2a. So that is the reason you can also say the equation of line of symmetry is x is equals to minus b over 2a. So this is your equation of symmetry. So now if I talk about the range of quadratic function. So whenever I say range of quadratic function, let's say I have the general form something like this. So in this case, what I could say is, so depends on the value of a, the concavity depends on whether it's concave up or concave down. So whenever it's concave down, I can say this will be my maximum point. This will be my maximum coordinate. And whenever a is greater than 0, this is, I can say, the minimum coordinate. So that is the reason I can say to find the range of any quadratic function. Range means all the possible values of y, and the y coordinate here will be k. So that is the reason the range of the function goes something like this. So whenever a is positive, your range of your function, which is f of x, will be greater than or equals to 0. Because whenever a is positive, not 0, greater than or is equals to k. So whenever a is positive, so the least value of your graph is k itself. And whenever a is less than 0, so whenever the graph is concave down, so your f of x, the range of your function is f of x is less than or equals to k, because k will be, whenever the graph is concave down, so k will be the maximum point. So now if I think about solving an example based on this, let's say it goes something like this. Let's say I have any equation in the vertex form. Let's say I have 2 into x minus 3 whole square plus 4. So in this case, as I can observe it very clearly, this is a quadratic equation. So in this case, the vertex of the graph is 3, 4 by comparing with the quadratic equation. So in that case, h value is 3 and k value is 4. So since a is positive, because a is 2 means the graph is going to be concave up. So since a is positive, I can say the range of this function, the range would be, which is f of x, or you can say y, will be greater than or equals to 4. If you graph it, you will get only possible values of y is greater than or equals to 4. In case if I had negative 2, then since a is negative, a is less than 0, so that is the reason the range would be y would be less than or equals to positive 4. The range of the function, or a maximum or a minimum value of the function, always refers to the y coordinate of your vertex.